train and test autonomous driving functionalities, we need large amounts of data. So let's look into a typical customer project. We have 300,000 kilometers of driving in raw, camera and LiDAR data. With 45 kilometers per hour, which is common across urban and non-urban scenarios, we end up with 6,700 hours of driving. A typical LiDAR spins at 10 frames per second. Taking this into account, we end up with 240 million frames to be annotated. But it's not only about the frames. On each frame, we have an average of 15 objects. Objects are cars, trucks, pedestrian, traffic signs. When we take these numbers, we end up with a whopping 3.6 billion objects to be annotated at quality. This is a lot. So the question is, how do we label 3.6 billion objects? So can this be done manually? Manually in the sense that you sit in front of your computer and you draw objects one after another. And the answer is no, this cannot be done manually. Not at this scale and not even if you have the best labeling crew in the world available. This just doesn't work out. In the past, it was done manually because the projects were much smaller. So you can do that at exactly that manner if the projects are small enough. But with ever more complex driving functionality and ever more complex validation requirements, there's also a higher amount of kilometers you have to annotate. And at the scale we talked about, there's only one way you can do that. And this is through automation. So you need robust, reliable automation which helps you to get the job done. To understand automation, you need to understand what manual labeling actually means. So let's go through the sequence of tasks you have to fulfill in order to produce a high-quality annotation. The first step is you have to navigate yourself through the LiDAR scan and through the cam footage. So what you typically have is you have a LiDAR scan with corresponding cam footage, and the LiDAR scan is a 360-degree LiDAR, for example, which is scanning the whole surrounding of the car. And then you have a variety of cams, maybe 8 or so, which then cover the same area from a cam perspective. Typically, there's a different angle and a different coverage for each cam and also for the LiDAR, and this is what makes it somewhat tricky to navigate yourself in this space. So once you did that, that's the first task. We assume it takes around 20 seconds on average. Then you move on to the second task. So now you know where objects are located, at least roughly. And now what you do is you do object detection. So this means within your 3D world, like in a game, you're navigating close to the object you detected. Let's say it's a car. And then you start drawing an as tight as possible box around this car. So you do that in 3D space, so you're doing a 3D box around that car. This task takes roughly 15 seconds on average to draw that box. Then you move on to the next task, so that's now the third task. It's typically not enough to just have a box, which is classified to be a car or a pedestrian or a motorcycle, for example. What you also need is certain attributes which better describe the object. So let's say you have a car. You would also be interested in turning signals, braking lights. Is it an emergency vehicle or not? Are there caution orange lights on or not? So these are the things you would need to know in addition. Or is it a moving, or if it's a static object, is it parked, and so on and so forth. And these are the attributes you assign in addition to your box to each of those objects. So there's a long list, and you go through it list one by one. You look at the cam footage, and then you say, okay, the blinker's on or blinker's off, and you move through that list. So this task takes another 10 seconds on average. Now you have a full annotation which is nicely describing the object. But that's still not enough. There's at least one more step which is absolutely important. To achieve desired quality levels, what we do is we have a second person looking on each of those annotations and making sure that it's actually a correct one, so that it is of high quality, high enough quality. So that person moves through every annotation and then checking if the box is tight enough, if it's the right class, if it has the right attributes on, and so on and so forth. We assume that this takes another 15 seconds on average. So if we sum that up, we end up on 60 seconds for a 3D bounding box. This is painfully slow. Now let's talk automation. Understand.ai developed the automation engine to bring down the times from 60 seconds to a significant lower amount of time to speed up those projects, to bring down prices. I now want to take the chance to explain how that is done. We start with automated object detection for cars, for example, via deep learning based networks. Then we track those objects across frames and link them into chains. Finally, we snap those objects to the perfect size via deep learning based regression. With the Understand.ai automation engine, data can be processed up to 15 times faster than manual labeling and up to 5 times faster than traditional automation approaches. This saves you cost and time. Sounds interesting? Contact us if you want to learn more.